8D, circles. So now we're going to get into circles, and we left circles out when we were dealing with perimeter and area because circles are a little bit different. We don't really get to measure the length of a side and work with it. We have other things that we measure, and we have to deal with a constant that I'm going to mention in just a moment. So a circle, and I'll do the best I can. Okay, it's not a great circle, but it'll do. A circle is a two-dimensional closed figure. It's the set of all points that are equidistant or the same distance away from some center point. We refer to that center point as the center. And if we mark every point that is a set distance away from that, we end up with a circle. That distance from the center to those points is the radius. And we usually use a lowercase r to indicate the radius. So a circle is all points that are r away from the center. Creates this circle. Another measurement which we have on this is the diameter. The diameter is the distance from one point on the circle to another point on the circle when the line passes through the center. So you can't do it as like this point to that point. That would be considered a secant. We're not going to deal with that. But diameter is a line that passes through the center of the circle, and it's the measure from one point on the circle to the other point on the circle when passing through the center of the circle. Now, as you should be able to see from that, then the diameter is really the radius plus the radius. So we can, and diameter we use a lowercase d. So we can say that the diameter is equal to 2 times the radius. Because that's a radius, and then that's a radius. So that's the diameter, 2 times the radius. When dealing with circles, we deal with a special constant. Remember, constant is a value that stays the same, and that constant is known as pi. Pi. It's a Greek letter. Looks a bit like that. So there's pi. When I write it, it tends to look a little bit more like this. When I tend to write it quickly. That's the Greek letter pi. Some people mock me and say that it looks like an upside down smiley face, but that's okay, as long as you remember it's pi. And pi is an irrational number. Irrational meaning, if we remember back when we were dealing with fractions and such, irrational numbers are numbers that do not terminate or repeat. So they go on forever without ever ending, terminating, or repeating. It's approximately equal to 3.14. It's really 3.14159, so it keeps going on forever, so I can't give you all those digits. But it can be approximated to 2 decimal places as 3.14. So many times we will use that approximation. Any scientific calculator has a pi button on it. And if you press that pi button, it will give you pi to however many digits that calculator shows on its display. So if I grab my calculator here and I use pi, I get 3.14159265359. And it rounded that last one. It obviously goes on forever, so that's still a rounded number. But pi is the ratio of the circumference to the diameter of a circle. And that's where pi comes from. And it was calculated many, many, many centuries ago. So, like I said, it's the ratio of the circumference to the diameter of the circle. So one of the first things we want to look at with this is the circumference of a circle, and that's a capital C. Well, what is circumference? Circumference is really the perimeter of a circle. So the circumference of a circle is really the perimeter of the circle. It's the measure of the outside. When we dealt with triangles, rectangles, and squares, we had lengths of sides to add up. We don't have that capability with a circle because there is no line segment on it. It's all points. So each side of it, you could say, is infinitesimally small, which means, in fact, it has a length of 0, which would be very confusing because then the circumference of this would be 0, because 0 times however many points there are, but there are an infinite number of points. So it just gets really confusing. We don't deal with that. But we know that pi is the ratio of the circumference to the diameter, so we can say that the circumference of a circle is equal to pi times d. So pi times d. We also know that d is equal to 2 times r, so we could also say that the circumference is equal to 2 pi r. It's really the same equation because 2 times r is d, so it's really just a matter of which one you prefer to remember, and do you have the radius or do you have the diameter when you go to find the circumference. So let's find the circumference of a circle. So let's get this out of the way. So let's say we have a circle with a radius of 7 feet, and we want to find the circumference of this circle. Then the circumference is equal to 2 times pi times the radius is equal to 2 times. Now we can use the pi button on our calculator, or we can use our approximation 3.14. I'm just going to use 3.14 here. So 3.14 times r, our radius of 7 feet. Two times 3.14 is 6.28 times 7 feet. I'm going to grab my calculator because 6.28 times 7 in my head is not a quick, easy calculation. So 6.28, 7 times, gives me a circumference of 43.96 feet. Remember that circumference is just the perimeter, so it's a length, so our unit will just be the unit. There's no squaring or cubing of that unit. So 43.96 feet. That was using, let's switch to a different color, 3.14 as an approximation of pi. If you used your calculator, then you would have a closer approximation of pi, which would actually be larger, 3.141592, right? So it's a large one, so we would get a slightly larger answer. So let me just do that and say if I go 2 times pi in my calculator, and then multiply that by 7, then I'm going to put this over here. Pi approximately equal to 3.14. That's where we got that number from. But plugging it in using the calculator to do the calculation, we got 43.982297 feet. And we see there's a slight difference there. We're off by, our difference is about 2/100ths of a foot. Not a huge difference. And considering a foot is 12 inches, 2/100ths of a foot, that's 1/50th. So you're talking about 1/4 of an inch. Not that big of a concern. If it is a concern, use the pi button on your calculator. Okay? So that's finding the circumference of a circle. Well, what did we do with our triangles and our rectangles and squares? Well, we also found the area. Well, the area of a circle is equal to pi times the radius squared. So the area is equal to pi r squared. If we want to find the area of a circle, then what if I have a circle with a diameter of 14 centimeters? So it has a diameter of 14 centimeters, so I'm going to put that up here. D is equal to 14 centimeters. Our formula for the area is A is equal to pi r squared. I don't have r, I have d. Well, remember that the radius is half of the diameter, so the radius must be 7 centimeters. And now I can find my area. The area is equal to pi times 7 squared. Now with that I can use 3.14, or I can use the calculator pi button. I'm going to do 3.14 times 7 squared is 49. So the area is equal to 3.14 times 49, which gives a 153.86. And it was centimeters, and remember this is an area, so that's centimeters squared. And that's using 3.14. If I use my calculator's pi button, then I would get pi and multiply that by 49, which would give me 153.938. So 938. So off by, call it 9.4, off by about 8/100ths of a square centimeter. So again, anytime you're dealing with using the approximation 3.14, your number is going to come out a little bit low, or a little bit lower than if you were to use the pi button on your calculator. Either one is okay. Just make sure that if you are using the approximation 3.14, that you show that when you're doing your work. Because if you don't, if you put this at area is equal to pi times 7 squared, and you come out with 153.86, then that's going to be wrong, because if you took pi and pi times 7 squared, you'd get 153.94. So by putting this 3.14 here, you're saying, I'm using the approximation, this is the value I got. If you didn't put that 3.14, then this indicates that you used the pi button on your calculator and you should have got a higher value. So just remember, as with our triangles, rectangles, and squares, when you're dealing with a perimeter, which for a circle is called a circumference, your length, they're going to be in units, whatever it is, centimeters, feet, inches, etc. It's going to be the straight units. If you're dealing with area, area is always squared, so you're going to have centimeters squared, feet squared, miles squared, whatever the case may be.